जी, can you hear me? आवाज आ रही है जी?
Yes, sir. Adi.
Yes, sir.
Okay जी.
Yes, sir. Yes, sir.
So let's continue. ठीक है जी. So what we have seen, so ZB is equal to beta times RE, and from the circuit, if we take a look, we can say that uh, IB is equal to VI divided by ZB, right? So what we can say that IB is equal to VI divided by ZB. Are you with me?
Yes, sir.
ठीक है जी. And we also know this thing if we write that IE is equal to beta plus 1 times IB, right? So what we can say that if we put the value of IB in this equation, so IE will be equal to beta plus 1 into VI divided by ZB, right? ठीक है जी. As we know, beta is a big value, so beta plus 1 is also equal, we can say it is equal to beta. So what we can say, IE is equal to beta times VI, where ZB is also equal to beta times RE plus beta plus 1 times RE. Are you with me? ठीक है जी.
Yes, sir.
Or what we can say that IE is equal to beta times VI divided by what we can say beta, and beta plus 1 is more or less equal to beta. So what we can say, we can take beta common from the denominator. So we have RE plus RE capital, right? ठीक है जी.
Yes, sir.
Or we can say beta can be cancelled out from beta. So what is left with us? IE is equal to VI divided by RE plus RE. Are you with me? We
Yes,
are
sir.
left with this thing, right? ठीक है जी.
सर ये आर ई तो स्मॉलर वैल्यू है तो फिर उसको अप्रोक्सीमेटली डिवाइड बड़ा आर ई के इक्वल नहीं.
अभी हमने अप्रोक्सीमेशन नहीं ली ना, तो वी हैव RE plus RE capital. Is this thing fine?
Yes.
ठीक है जी. ZB की हमने वैल्यू डायरेक्टली बस पुट कर दी है इसमें. क्वेश्चन?
No, sir.
ठीक है जी. Now if you see this equation, and from this equation if we try to make a circuit, how this circuit will look like? Just take a look. So we have this equation, and from this equation if we do the reverse engineering, right? If we do the reverse mechanism, so how we can actually make a circuit from this equation? Can you do that?
Yes, sir.
सोच के सर करेंगे.
Yes, sir. ये हो जाएगा. आर ई और आर ई दोनों सीरीज में लगेंगे और वोल्टेज सोर्स होगी और करंट होंगे.
Right? So what we can do from here, that we can say that let's suppose this is the input VI, right? Then we have small re, and then we have capital RE, right? So what we can say that let's suppose the current flowing over here is IE over here. Are you with me? Is
Yes,
everyone
sir.
Yes, sir.
fine?
Yes, sir.
ठीक है जी. So this is the equation. IE is equal to VI divided by RE plus RE. And once this is the equation, so doing the reverse engineering, we are going to get this circuit from this equation. Are you with me? Right?
Yes, sir.
Now, if we go back to our original circuit, what we see that across RE, we are taking the output V naught, right? ठीक है जी?
Yes, sir.
So this means from this circuit, which we have just developed from the equation, we can say that across this RE, we will be taking our V naught, right? And by looking from this side, we will actually find Z naught for the system. Are you with me now?
Yes, sir. Yes, sir. Yes, sir.
Yes, sir.
And from here, to find out Z naught, what is the condition? To find Z naught, the condition is, the condition is we have to put Vi equal to 0, right?
Yes, sir. Short.
Now, when we put Vi equal to 0 in this circuit, so this circuit will behave as, this means this, there is no Vi, right? And when there is no Vi, so this means the voltage source is going to be short circuited, right? And once it is going to be short circuited, so this circuit, how this circuit will look like now?
RE is parallel to R.
RE will become parallel to small re, right? Are you with me?
Yes, sir.
Right? So in that
Yes,
specific
sir.
case, what will happen that Z naught will be equal to RE in parallel to small re, right? Okay, ji? And as we know, small re is
RE
very,
is
very
very, very
small
small.
than capital RE. So what we can say is Z naught is approximately equal to RE, right? Okay. Any question?
Yes, sir. No, sir.
And from the circuit, if we take a look, if you see from the circuit, V naught should be equal to, in terms of Vi. If you want to see what is going to be the value of V naught in terms of Vi.
VI into capital RE divided by RE plus small r.
बस आपने तो मसला ही हल कर दिया, ठीक है जी. So if we take a look from here, or if whatever mechanism if you want to do, so we can say that V naught should be equal to, V naught should be equal to, from here, V naught should be equal to Vi into capital RE divided by RE plus small re. Are you with me?
Yes, sir.
ठीक है जी. So this means V naught divided by Vi will be approximately, or will be equal to Re divided by Re plus small re, right? And this is basically our voltage gain for the emitter follower configuration circuit, right? as we know that RE is very, very big than small RE. So in the denominator, we can say RE is, it is in the denominator, we can say it is more or less equal to RE. So then we can say it is approximately equal to 1. Are you with me?
Yes, sir.
So this means in emitter follower configuration, the voltage gain is almost 1, and there is no phase shift between input and that of the output of the waveforms in the voltage. Right? Okay, ji? Are you with me?
Yes, sir.
Okay, ji? So with this, there is an example 5.7. Example 5.7 is the assignment. As well as what you can do, you can go through the topic, which is topic 5.9, common base configuration circuit, right? So in that common base configuration circuit, you will apply the RE model for the common base configuration circuit, right? And once you put in the RE model for the common base configuration circuit, you can go through this topic as well. Okay, जी?
Yes,
ये
sir.
असाइनमेंट में लिख लें या सिर्फ पढ़ लें?
नहीं, ये असाइनमेंट में लिख लें और इसके साथ एग्जाम्पल 5.8 को भी इसके साथ कर लें. ठीक है जी?
सर 5.1 से लेकर 5.8 तक और ये 5.9 टॉपिक बस.
5.9 टॉपिक और 5.1 से लेके 5.8 एग्जाम्पल्स तक. ठीक है जी? सो दिस इज ऑल.
सर ये
जी.
5.9 टॉपिक तो सिर्फ देखना है, असाइनमेंट में लिखना नहीं, ये तो खुद अपने साथ नोट करेगी ना 5.9
नहीं,
टॉपिक.
इसे कर लें. असल में जब आप इसे करेंगे ना तो आपको एक क्लियर आइडिया हो जाएगा. ठीक है जी? सो डू राइट इट.
सर मेरा मतलब है हम करेंगे लेकिन अपनी नोट्स में करेंगे, असाइनमेंट में इसको
सबमिट नहीं
करिए
करना
ना.
मतलब के.
नहीं, सबमिट भी करें इसको. ठीक है जी?
ठीक है, ठीक है,
हाँ,
ठीक है.
फिर सर को कैसे पता चलेगा कि किए
हाँ.
नहीं किए? ठीक है, सब
ठीक है जी,
सबमिट
इसे
करें.
सबमिट भी करा. So this is all included
Yes,
in the assignment, and the assignment will be due next Tuesday, right?
ठीक है सर.
ठीक है जी?
यस सर,
Okay.
यस. अभी तो लिंक भी नहीं आया उसका.
खैर है, आ जाएगा वो, आपको आ जाएगा. ठीक है जी? Okay, that's it for
यस.
today. Thank you.
थैंक यू सर. थक गए सर.
थैंक यू सर जी.
Thank you.
थक गए सर जी.